Okay, so this is a video of me working out the questions from the 5.2 worksheet, simplifying the fundamental identities, okay? So for the first one, it says use the fundamental identities to simplify the following expressions, okay? So you have tan of x times cosine of x, okay? So I know tan of x is the same thing as sine of x over cosine of x, so times cosine. So those cosine terms are going to cancel, so then you're left with just sine of x. Okay, so for the next one, 1 minus cosine squared over sine. So I know that sine squared plus cosine squared is 1. Okay, so if I solve that for 1 minus cosine squared, the top part is just going to become sine squared. Okay, so sine squared over sine, it's like you're doing x squared over x, is just sine of theta. Okay, and then the third one, now again, you're allowed to rearrange the top if you'd like. And if you do that, right, if you put sine squared plus cosine squared together, right, we know that that's going to come out to be 1. So this is 1 plus tangent squared over secant squared. Okay, and then there's another identity that says 1 plus tangent squared is secant squared. Okay, so I'm going to substitute that in there in the top. So secant squared over secant simplifies to just be secant. Okay, now the number 2 says simplify the following to a constant or a basic trig function. Okay, so how can we do that? Well, there's a couple ways you can do it. Maybe the easiest way to go about it would be just to put everything in sine and cosine and then kind of go from there. So if I do that, right, I'm going to do 1 plus sine over cosine divided by 1 plus cosine over sine, right? Now I have a fraction that I want to simplify, right? So I need to multiply the top and the bottom by the common denominator, which would be sine times cosine. Remember, you need to multiply that to everything. Okay, so when I distribute now, this is going to be sine cosine plus, if I multiply it to this term, right, the cosines are going to cancel each other out. So then you're going to be left with sine squared. And then if you do the same thing on the bottom, you got sine cosine plus, if you do it to the second term, the sine's going to cancel. So then you got cosine squared. Okay. Now, you can look to factor now on the top and the bottom, right? So I could take out a sine term in the top. That's going to leave me with cosine x plus sine. And then I can take out a cosine term in the bottom, which is then going to leave me with sine of x plus cosine. Okay. Now, cosine plus sine and sine plus cosine are the same thing. All right. So we can cancel that factor out. All right, so then that's going to leave you with sine over cosine, which simplifies to just be tan x. So that is your final answer. Okay, the second one, all right, again, a couple ways that you can kind of go about this. If you distribute now the negative sign, all right, this is going to give you secant squared plus cosecant squared minus tangent squared minus cotangent squared. Okay, now the identities that we have for secant squared, cosecant squared, tangent squared, cotangent squared, right? You got 1 plus tangent squared is secant squared, okay? So now if I rearrange some of these, right, and say I did secant squared minus tangent squared, I know that that's going to come out to be 1, okay? So if I take this term and this term and I put them next to each other, okay, now I have what I want. So now I got secant squared minus tangent squared, now plus cosecant squared minus cotangent squared, okay? Now another one you can do is also, you have 1 plus cotangent squared equals cosecant squared, okay? If you subtract the cotangent squared over, that leaves you with cosecant squared minus cotangent squared, okay? So again, if I put these two together, I know that it's going to come out to be 1, okay? So secant squared minus tangent squared we know is 1, plus cosecant squared minus cotangent squared is also 1. So your final answer is just 2. Okay, number 3 says change each expression to only involve sine and cosine and then simplify to a basic trig function. Okay. I think I'm going to do that for the first and the third one. I don't know if I'm going to do that for the second one because it's a little bit easier to do it a different way. But I'll show you what I mean when I get there. So sine and cosine, right? So we got sine times sine of x over cosine plus cosine over sine. Okay. Now, if I distribute, right, I got sine squared over cosine plus, when I multiply sine with the second term, the sine term cancels out. So that just leaves me with cosine x, okay? Now, I want to make this one function, so I need to multiply here by cosine over cosine to get a common denominator. Okay, so now if I do sine squared over cosine, now this is going to give me cosine squared over cosine, okay? Now sine squared plus cosine squared is 1, so now you got 1 over cosine x, which is then secant x. Okay, now for this one, I know it says to change the sine and cosine, and you can certainly do that. I think it's just going to take you a little bit longer to come up with your answer. I think it's a little bit easier if we just multiply out. Okay. Now your top factors are factors to a difference of two squares, right? So secant times secant is going to be secant squared. Secant times tangent, secant y, tangent y, minus secant y, tangent y, and then minus tangent squared over secant. Okay, so obviously the middle terms are going to cancel. So now I got secant squared minus tangent squared divided by secant. Okay, now I know that 1 plus tangent squared is secant squared, right? So what is going to be secant squared minus tangent squared? Well, that's just going to be 1. Okay, so you got 1 over secant, which comes out to be cosine. Okay, I'm going to move that over. Okay, and then the third one, here I am going to change everything to sine and cosine. So I got 1 over cosine squared A times 1 over sine over, I got 1 over cosine squared plus 1 over sine squared, right? So what do I need to multiply so that all my fractions get eliminated, right? So obviously sine and cosine, right? But I need to multiply by the one with the highest exponent because that'll help me eliminate those terms. So I'm going to do sine squared and cosine squared. Now you need to remember that you're multiplying this to everything. Okay, now you only have one term in the top because technically these are being multiplied together. So sine squared, cosine squared is going to go on the top, right? So this cosine squared is going to cancel out that cosine squared, and then this sine is going to cancel out one of those sines. Okay, so you're just going to be left with sine of A on the top. Okay, and then here you have two terms in the denominator. So when you multiply to the first one, cosine squared would cancel. So you got sine squared. And then the second one, sine squared is going to cancel, and then you're left with cosine squared, which at this point you should know that turns into just 1. So you got sine over 1, which is just sine. Okay, number 4 says combine the fractions and then simplify to a power of a basic trig function. Okay, so how can we go about that? Well, let's, when in doubt, change everything to sine and cosine, right? So the first one's already in sine, okay, so that's 1 over sine squared. Okay, plus 1 over cosine squared divided by sine squared over cosine squared, right? Okay, so what's that going to give me? So I got 1 over sine squared plus 1 over cosine squared times the reciprocal of the denominator. So that's cosine squared over sine squared, right? And then obviously your cosine squareds are going to cancel. So you got 1 over sine squared plus 1 over sine squared, which is going to give me 2 over sine squared, right? And then what's the reciprocal of sine? It's cosecant. So your final answer is just 2 cosecant squared. Okay, second one. Now we want to combine the fractions, right? So we got to find a common denominator. All right, so for the first one, I'm going to need to multiply by secant plus 1. And then the second one, I'm going to need to multiply by secant minus 1. Okay, so when I do that now, right, I'm going to have secant of x plus 1 over, now secant of 1 minus 1, secant plus 1, is just going to be secant squared minus 1, okay, minus secant of x minus 1 over secant squared minus 1. So now I got the same denominator. So I want to combine what I see on the top. So on the top, I got secant minus secant, which goes away, And then I got 1 minus -1, which is going to give me 2. Okay, now what could you change the denominator to come out to be? Well, that's a Pythagorean identity. So now you got 2 over tangent squared. 1 plus tangent squared is secant squared. So if you move the 1 over, that's how you get tangent squared. And then the reciprocal of tangent is just cotangent. So you got 2 cotangent squared. Okay, and then the third one, we need a common denominator, right? So got to multiply the first one by sine over sine. And then the second one, by 1 minus cosine. Okay, so if you put the top together, right, you got sine squared over 1 minus cosine times sine, okay, plus, right, now it's not a difference of 2 squares, right, because they're both 1 minus cosine, okay, so what I'm going to do is you just need to FOIL that out. So you got 1 and then minus 2 cosine x plus cosine squared over sine times 1 minus cosine. All right, so if I put that together now, right, I got sine squared plus cosine squared minus 2 cosine plus 1 all over sine times 1 minus cosine. Okay, well, I know I have sine squared plus cosine squared is going to give me 1. Okay, so this here is just going to be 1. Now, if I put that with the other one, now I got 2. So 2 minus 2 cosine over sine 1 minus cosine. All right, now if you look in the numerator, right, you can take out a 2. So that's 2 times 1 minus cosine divided by sine 1 minus cosine, right? And then you can obviously divide that out. So 2 over sine, what's the reciprocal of sine? It is cosecant. And that is your final answer for that one. Okay, now the next one says simplify by factoring. Okay. Now, typically when you're factoring, it's probably helpful to put everything in the same function, kind of like the same term. So what could I change 1 minus cosine squared to be, right? So if you use the identity, you know that this is going to be just sine squared. So you got 1 minus 2 sine plus sine squared. Okay, so now if you rearrange, if you rearrange it, you got sine squared minus 2 sine plus 1, right? Now treat sine of x like a variable, right? So technically, when it says sine squared, it's like you have, a squared, and then minus 2a plus 1, okay? So how would you factor if you had this quadratic, right? This is really just a minus 1, right? So it's going to be the same thing here. So I'm going to have sine minus 1, sine minus 1. All right, so if you put them together, you got sine minus 1 squared. Okay, so for the second one, you got 4 tangent squared. Now, 4 over cotangent is the same thing as 4 tangent, okay? It's easier to put everything in the same function. And then sine times cosecant, they're reciprocals of each other. So they're just going to become 1, all right? So now what your equation kind of looks like is you have 4a squared minus 4a plus 1, okay? So the same way that you would factor that one, which is just 2a minus 1 squared, is how you would factor this one. You're going to treat your variable like tan x, okay? So this is 2 tan x minus 1 times 2 tan x minus 1. So 2 tan x minus 1 squared. Okay. All right, now again, we have tangent squared, which is not in terms of secant, right? But how could we change that, okay? So if you look at your identities, right, 1 plus tangent squared is secant squared. So if you move the 1 over, you know that tangent squared is the same thing as secant squared minus 1, okay? So this now gives you 2 secant squared minus secant minus 1. All right, so if you factor, all right, so that's 2 secant, so this would be minus 1 plus 1. All right, so if you guys again treat the trig functions like variables if you're trying to factor. Okay, number 6 says simplify by factoring and then dividing out. Okay. Now the top one, right, 1 minus sine squared, right, is almost like you have 1 minus a squared, right? So that's a difference of 2 squares. So it'd be 1 minus a, 1 plus a, right? So I'm going to write it the same way here. I'm going to treat sine of x like my variable. So the top now becomes 1 plus sine of x times 1 minus sine of x divided by 1 minus sine of x. Okay, obviously that's going to cancel, and then you're just left with 1 plus sine of x. All right, now if you do the same thing for the second one, okay, so this is to be 1 plus tangent of b times 1 minus tangent of b divided by tangent of b plus 1. Okay, obviously tangent of b plus 1 is the same thing as 1 plus tangent of b, so your answer is just 1 minus tangent. Okay. All right, now for the third one, we're going to need to change tangent squared, okay, so that we have everything in the same function, okay? So you can change the top to be secant squared minus 1, okay? That's an identity. All right, so if you factor now the top, you got secant plus 1, secant minus 1, divided by secant plus 1. So that cancels, and then you got secant minus 1. Okay, and then the last one. All right, so for the first one, it looks like I can factor. All right, so I can take out a cosine. So this is now cosine squared plus sine squared. okay, which is very nicely just 1. So cosine of x times 1 is just cosine of x. Okay, number 2, I'm going to change everything in sine and cosine. So tangent just becomes sine over cosine times cosine times 1 over sine. Okay, so cosine's going to cancel, sine's going to cancel, and then you're just left with 1. Okay, third one. Again, I think we're going to change to sine and cosine. So you got cosine of theta over 1 over secant, or not 1 over secant, 1 over cosine is secant, plus sine over cosine. Okay, so if you put the denominator together, because they have the same terms in the denominator, right? You got 1 plus sine over cosine. Okay. Now, if you simplify that, right, it's cosine times the reciprocal of the denominator, right, which is going to give you cosine squared over 1 plus sine. All right. Now, if you think of, all right, what's cosine squared the same thing as if you use the identity, right? Cosine squared is the same thing as sine squared, or 1 minus sine squared, sorry. So you got 1 minus sine squared over 1 plus sine. Okay, so now if you factor the top, like we've been doing, okay, I'm going to cancel, and then that's going to leave me with 1 minus sine of theta. Okay. All right, now the last one. So again, like I said, it's probably easiest to put everything in the same term with each other. Okay. So what's a way that I could change tangent squared so that it's in terms of secant? Okay, so 1 plus tangent squared is secant squared, right? So if it's just tangent squared, we know that it's secant squared minus 1. Okay, now if I simplify the top, right, that's going to give me secant squared plus 1 over secant squared. And I'm missing this other one. Okay. Now, you really can't factor the top here, secant squared plus 1, okay? But you do have a single term in the denominator. So if you split this fraction up, okay? So you got secant over secant, and then 1 over secant, right? So secant squared over secant squared is 1, plus 1 over secant squared is cosine, okay, and then minus 1. So obviously the 1s are going to cancel, and then you're left with cosine squared. Okay. So that is the 5.2 worksheet of simplifying the identities.